Okay. So, let's see. I want... Okay, so let's say that the average speed on a stretch of highway is 56 miles per hour. That's the average. And the standard deviation is 4 miles per hour. A z-score is defined as how many standard deviations a data point is from the mean. So, let's suppose that I had a car that was going 60 miles per hour. What would their z-score be? 1. Okay, what if I had a car that was going 52 miles per hour?
Still 1.
Actually, -1. So z-scores can be positive or negative, and so it's on either side of a bell curve. This only works with a bell curve. This is how they figure out percentiles and stuff. Do you remember when we were looking at empirical rules? The empirical rule, and we were looking at that colorful bell curve, right? And we know like what percent everybody is at 1 standard deviation, 2 standard deviation, 3 standard deviations, and so on. Okay, right now, what I want you to do with your partner is tell me if I had a z-score of 3 on this road, how fast would that person be going? Talk to your partner. So it's 3 standard deviations above the mean, and each standard deviation is 4.
I would personally z-score times your standard deviation added to x. That's what I would do.
Alright, I've got some wild animals out here. I've got some pickled candy if anybody's interested in that. And some gum in my desk if somebody wants to have that instead. Alright, anybody want to raise their hand individually? Doesn't have to be with your partner. It can be anybody who wants to. Nathan.
68.
Let's see, yes, 68. 68 miles per hour. So basically what you did is you took what?
I did 3 times 4.
Mm-hmm. So that's 12, and it's 12 above the mean. And the mean was 56?
Yep.
Okay. Is that making sense to you two? No? Okay. So let's put it this way. Everybody draw a bell curve.
Is that one prize-worthy?
Yes, it is. Go get a prize, please. Okay. Draw a bell curve, have a mean in the middle, and then put 3 lines like that. So we have that the mean was 56 miles per hour, right? And that each standard deviation, every sigma, is 4. So if they were 1 standard deviation above the mean, they'd be at 60. Is everybody understanding this so far? What's the next one? 64, and then 68 is over here. This is 1 standard deviation above the mean, this is 2 standard deviations of the mean, this is 3 standard deviations above the mean. What's the z-score right in the middle?
0.
0. What were you going to ask me?
Why
because it was 3 of these. So 1, 2, 3, 3 times 4 told us this distance. And that's because the standard deviation was 4. Tell me what you're confused about. Okay, so each one of these is 4, right? So what's this one? 52, and then 48, and then 44. What are the z-scores down here? Negative 1, negative 2, negative 3. So these right here, these are z-scores. But it's pretty rare for somebody to be exactly 1 standard deviation of the mean, above the mean, or exactly 2, or exactly 3. So we need a formula that helps us figure that out. So we need a z-score formula. So let's say, let's do it this way. Somebody tell me, if you were 2.5, if you had a z-score of 2.5, how fast would you be going?
66.
You can see right here it's 66, right? But let's say you didn't have the picture in front of you. How would you figure it out? What would you do in your head?
Multiplied by the, what's it called? Or, yeah.
Sigma. Yep,
Yeah.
by the standard deviation. You could say it that way, yep. Okay, so if I wanted to find it out, if I wanted to find out what the score was, I would take the 2.5, right, times the sigma. So I take the z-score times the sigma. But that would just tell you what? 4 times 2.5 would be
6? Wait,
10.
oh, 4.
4 times 2.5 would be 10, right?
Yeah.
But then 10 isn't the right answer. The answer is 66. So what would I have to do then?
Add it to the mean.
Good, add it to the mean. Okay, so this is the formula. It is x equals z times sigma plus mu. But we really want a formula that says z equals, how to figure out a z-score. So can you guys tell me how I can solve for z right now? What should I do to get z by itself?
Find it from both sides.
Oh, I would, but first I got to get rid of this mu. So I'm going to subtract mu from both sides. Just like I would a normal equation. And now I'm going to divide it out. So I'm leaving the z by itself, so what should I divide out? Sigma. So the formula is, we're going to write it down over here, the formula for a z-score is x minus mu over sigma. I'm going to sing that to you a lot. I'm so sorry. It will help you remember it, or it will be annoying, and both are wins in my book. X minus mu over sigma. Okay, let's say somebody was going super slow on this road that is, we got like a grandma driving, right? She's going out for her 1 time a month that she goes out and she buys groceries at the store. She's like gripping on the steering wheel. Her eyes are like barely over the top of it. She's going as slow as humanly possible. How slow is she going, Jessica? You pick. There isn't a right answer, just pick. Average is 56. 44? Okay. She's going 44. Well, we already know what 44 is. Pick something that is not on this.
I did that on purpose.
I know you did. Okay, fine. We'll use 44. All right, so we're going to use 44. 44, if I'm using this formula, minus 56, which is the mu, divided by 4, which is the standard deviation. Everybody, you can do this in your calculator if you want. Make sure you put parentheses around the top. 44 minus 56, or you can do it in your head. What's 44 minus 56? If you don't know, grab a calculator. Grab a calculator. Go get one. Everybody go get one no matter what. Negative 12. And then you divide by 4, which gives you? Negative 3. Do you see how it works? Actually, that was probably a good example to do. Good job, Jessica. To come up with one that we already know. Okay? Let's do one that we don't know now. an older granny who's very concerned about her life and the safety of everyone around her, which is very funny because she's driving so slow that she's actually making things more unsafe. Very ironic. She's going slower than 44. How slow is she going? 27? 17. Ooh, 17. She's going 17 miles per hour.
On a 56.
Mm-hmm. X minus mu over sigma, 17 minus 56 divided by 4. Everybody try it, please. Oh, and Jessica.